Welcome, comrades perennials, to another episode of the audio podcast Synthetic. Artificial intelligence will not replace you, but someone using artificial intelligence definitely will. So usually when you think about studying a natural disaster, there's this expectation of, immediate visible cause and effect.
Right, yeah, like a fault line ruptures and the ground shakes.
Exactly. The damage is right there on the surface for everyone to see. It's terrifying, sure, but it makes intuitive physical sense.
Yeah, it's something we can easily wrap our heads around.
But today, we're looking at the March 11, 2011 Tohoku earthquake.
Yeah.
And, we're not just looking at the devastating surface impact that you're probably already familiar with.
No, there's actually a hidden 15-year mystery that was buried deep inside the data from that exact day.
Yeah, and it was only recently solved in a groundbreaking 2026 scientific discovery. Discovery that leads straight from the shattered coastline of Honshu right down to the molten center of the Earth.
I mean, to understand this, we first have to talk about the raw, staggering power of the March 11 event. It fundamentally reshaped the geography and the geophysics of our planet.
Oh, absolutely. The numbers are just mind-boggling.
They really are. We're talking about a magnitude 9.0 to 9.1 undersea megathrust earthquake. It released an estimated 1.9 times 10 to the 17th joules of energy.
Which is just a massive number. Hard to even picture.
Right. To put that abstract number into perspective, it's the equivalent of a 100 megaton explosion. Or think of it as enough raw energy to power the entire city of Los Angeles for a full year.
Wow. And all of that was unleashed in just about 6 minutes, right?
Exactly, just 6 minutes. And the immediate geophysical effects were entirely unprecedented in modern recording. I mean, the main island of Honshu was physically moved 2.4 meters to the east.
Wait, it literally stretched the country?
Yes, literally. And it didn't stop there. The Earth itself was shifted on its axis by an estimated 10 to 25 centimeters.
That is just wild to think about, the whole planet wobbling.
Yeah, and because of that massive redistribution of the Earth's crustal mass, the planet's rotation actually sped up. It shortened the length of the day by 1.8 microseconds.
Unbelievable.
And the sheer force generated these infrasound waves that were detected by a low-orbiting satellite in space. It even caused an ice stream in Antarctica to physically slip.
So it's literally a global event.
Yeah.
And then, of course, when you factor in the human toll, the massive tsunami waves over 40 meters high, the Fukushima nuclear disaster.
Yeah, the severity of this planetary event becomes almost incomprehensible.
So to visualize this massive accumulation of energy, let's picture like a continental scale rubber band.
I like that.
Yeah, so off the east coast of Japan, the Pacific plate is subducting. It's actively sliding beneath the plate that holds northern Honshu. And this happens at this microscopic but relentless rate of about 8 to 9 centimeters a year.
Which doesn't sound like much, but it adds up.
Right. For decades, or even centuries, this colossal rubber band was just being wound tighter and tighter. It's dipping downward, building up enormous elastic energy, because the massive slabs of rock are locked together by extreme friction.
And seismologists actually thought a magnitude 9 was impossible in this specific area.
Really? Why is that?
Well, the fault line wasn't particularly straight. They assumed those jagged edges would prevent a massive singular rupture. But, the tension just kept building.
Until, in an instant, it snapped. The entire coastline lurched forward and downward.
Exactly.
But here's the thing. With a planetary restructuring of that magnitude occurring on the surface, the ground accelerating at nearly 3 times the force of gravity, how could scientists possibly notice anything else hidden in the data?
It does seem impossible, doesn't it?
Yeah, there must have been an overwhelming amount of noise. How do you isolate secondary anomalies in the middle of a 2.4-meter continental shift and thousands of violent aftershocks?
Well, the initial data was definitely an overwhelming, chaotic mess of signals. But thankfully, a massive network of over 1,200 continuous GPS stations had been deployed across Japan prior to 2011.
Oh, right, the GNet system.
Exactly, along with thousands of highly sensitive seismometers. It created the most thoroughly instrumented natural disaster in human history up to that point.
So they had eyes on absolutely everything.
Every microscopic physical movement of the crust, every vibration was logged with pinpoint accuracy, and hidden within that vast terabyte-sized archive of raw data was an anomaly.
An anomaly that just sat there unresolved until June 2026.
All right. That's when Sun-Young Park and her team at the University of Chicago published their paper in the journal Science.
So what exactly did they find in all that data?
They found that exactly 15 minutes after the main shock of the earthquake had initiated, that dense network of GPS stations registered an unambiguous step-like eastward displacement.
Okay, but how big was this displacement?
It was tiny. It measured just 5 to 6 millimeters.
5 to 6 millimeters. That's barely anything.
True, but the peculiarity of this specific movement was its perfect, instantaneous synchronization. This 6 millimeter shift occurred almost simultaneously across the entirety of the Japanese landmass.
Almost simultaneously. That's really weird.
Yeah, it happened entirely too late to be part of the main crustal rupture, which had ended minutes earlier, and its signature did not match any known type of aftershock.
So it was just this unexplained signal sitting there for 15 years.
Exactly. A tiny ghost in the machine defying conventional seismological models.
Okay, but I have to push back here. I am struggling to understand why anyone would obsess over a minuscule 6 millimeter shift when the whole island had just moved nearly 2.5 meters.
I get that. It seems insignificant in comparison.
Right. I mean, 6 millimeters is roughly 1/4 of an inch. It's literally the thickness of a standard pencil.
Oh, yeah, it's very small.
When you have an entire landmass subjected to the most violent shaking imaginable, a 6 millimeter shift sounds like, I don't know, a simple glitch in the GPS software.
It could definitely look like that at first glance.
Or perhaps just a normal settling of the Earth's crust as the tectonic plates grind to a halt and find a new physical equilibrium.
Well, it's a fair question, but
Demanding a complex, novel scientific explanation for such a tiny movement seems like agonizing over a single shifting grain of sand immediately after witnessing an entire mountainside collapse in a massive landslide.
it's a vivid way to put it, for sure.
Why couldn't this tiny pencil-thin movement just be an artifact of the physical instruments recovering from the violent shaking? Or just the ground naturally settling?
Well, the impossibility of a simple surface explanation lies entirely in the timing and the scale of the physical synchronization.
Okay, break that down for me.
Think about a normal settling of the crust, or a traditional aftershock. They propagate from a specific epicenter outward, much like a ripple traveling across the surface of a pond.
Right, they start at one point and spread out.
Exactly. Because seismic waves travel at finite, measurable speeds through the solid rock of the crust, different GPS stations would record the physical movement at different times.
Oh, depending on their exact physical distance from the source of the rupture.
Precisely. But this 6 millimeter shift occurred across a 3,000-kilometer area at virtually the exact same moment in time.
Oh, wow. So it didn't spread out at all.
No surface event, no localized aftershock, and certainly no software glitch could perfectly synchronize a physical displacement across the entire length of a country.
That mathematically doesn't work for a surface event.
Exactly. The mathematical impossibility forced scientists to abandon the crust altogether and look downward for an answer.
So they had to find something that hit the whole underside of the plate at once.
Yes, they had to seek a physical mechanism capable of striking the entire landmass from below, rather than propagating laterally from the side.
So to hit the entire country from below simultaneously, the source of the physical force had to be coming straight up from the deep interior of the planet.
Got it.
We are talking about energy traveling thousands of kilometers beneath the surface and then returning.
Yes, the physical mechanism scientists eventually identified is known as an SCS wave.
An SCS wave. What exactly is that?
Well, when the megathrust fault ruptured off the coast, it generated multiple types of seismic waves radiating in all directions. One specific type, a shear wave, traveled straight down from the earthquake's epicenter.
Straight down. How deep?
It dove 2,900 kilometers through the solid, superheated rock of the Earth's mantle. But when it reached the boundary of the Earth's outer core, it encountered a profound physical barrier.
What kind of barrier?
To understand why, we have to look at how different waves move. Compressional waves, or P waves, move like a slinky being pushed and pulled. They can travel through liquids, solids, and gases.
Okay, so they can go through pretty much anything.
Right, but shear waves, or S waves, move material perpendicular to their direction of travel. Think of it much like shaking a heavy rope up and down.
Oh, I see. So they need something solid to shake.
Exactly. They require a rigid medium that resists shear stress to propagate. And the Earth's outer core is composed of swirling, superheated liquid iron and nickel.
And liquids can't hold that kind of tension.
Right, because liquids inherently cannot sustain shear stress. They simply flow out of the way. The shear wave could not penetrate the core.
So what happens to it? It just stops.
No, instead it bounced off the core mantle boundary, reflecting straight back up toward the surface of the Earth.
That is incredible. So it just bounced right back.
Yes, and the 13-minute round trip of this wave through the deep mantle perfectly accounts for the 15-minute delay registered at the surface.
Wow.
Yeah. When this specific wave returned, it hit the underside of Japan with an unprecedented peak-to-peak amplitude of over 1 centimeter.
Okay, so we can visualize this underground journey by imagining like dropping a massive heavy boulder into a very deep swimming pool.
Sure, that works.
You stand at the edge and watch the primary ripple travel all the way down through the water, strike the solid concrete bottom of the pool, and then reflect, bouncing back up to the surface.
Exactly like that.
Only in this specific case, the returning ripple arrives with enough concentrated kinetic force to physically move a heavy floating raft resting on the surface of the water.
That's a really good way to picture it.
Understanding the physical journey of this wave perfectly explains the mystery of the 15-minute delay. The physical time it took for the seismic energy to travel down to the liquid iron core and reflect back accounts perfectly for the timeline of the GPS anomaly.
It matches up beautifully.
But we are still left with a massive logical leap regarding the physical force involved in this event.
How so?
Well, it is incredibly difficult to comprehend how a mere echo, a wave that has traveled nearly 6,000 kilometers round trip through dense mantle rock, could do this.
Right, because it's dissipating energy every single kilometer of the way.
Exactly. How could it possibly retain enough physical force to permanently displace an entire country by 6 millimeters?
That's the key.
Yeah.
But the returning SES wave did not move the country purely through its own brute kinetic energy.
It didn't.
No, the wave itself lacked the sheer physical force to simply push the entire landmass of Japan 6 millimeters to the east.
So what actually moved the ground then?
Instead of pushing it, it acted as a highly specific physical trigger. The mechanics of this SES-triggered slip rely entirely on the extreme pre-existing tension within the fault lines surrounding the region.
Oh, so the tension was already there, waiting to be released.
Exactly. The returning wave arrived, synchronized across the entire underside of Japan, and its vibration provided the exact microscopic physical nudge needed.
A nudge to trigger a multi-plate interface slip on the already stressed megathrust faults.
You got it. The seismic echo essentially lubricated the fault lines for a brief moment. It unlatched the microscopic friction holding the rocks together and allowed the immense built-up tectonic tension to slide the plates just a little bit further east.
So it just kind of jiggled the lock.
Yes. And this secondary slip spanned an unprecedented 3,000 kilometers.
3,000 kilometers? That's massive.
It is. It's more than twice the length of the massive 2004 Sumatra earthquake rupture.
Wow.
And this secondary event, triggered entirely by the core reflection, released energy equivalent to a magnitude 7.5 earthquake.
That is huge.
It really is. It represents a completely previously unrecognized source of global seismic hazard. It proves definitively that a core-reflected wave can return to the surface with enough localized amplitude to unlatch a stressed fault.
And cause a massive secondary rupture.
Exactly.
But, I have to say, the true danger of this newly discovered hazard seems highly questionable when you look at the physical reality of what occurred on the surface.
What do you mean?
Well, you are describing a massive 3,000-kilometer fault slip, releasing the raw physical energy of a magnitude 7.5 earthquake, yet it was completely imperceptible to any human standing on the surface of Japan at the time.
That is true. Nobody felt it.
If this massive secondary slip happened over the course of 3 full minutes and only moved the ground by 6 millimeters without a single person feeling the vibration, calling it a major global seismic hazard feels like a dramatic exaggeration of the facts.
I can see why you'd say that.
Right. An event that causes 0 structural damage, goes completely unnoticed by the public, and requires 15 years of supercomputer data analysis to even detect in the records. That does not sound like a legitimate threat to human life.
It sounds harmless.
Yeah, it sounds much more like a fascinating but ultimately harmless geophysical curiosity buried in the noise of a much larger disaster.
Well, here's the crucial distinction. The 2011 core bounce slip was slow, benign, and completely imperceptible, specifically because the massive amount of energy was distributed over a 3,000-kilometer area and released gradually over 3 full minutes.
Okay.
This is known in seismology as a slow slip event, where the fault moves but without the violent high-frequency shaking that destroys buildings.
So we got lucky that it was a slow slip.
Exactly. The actual hazard lies in the physical mechanism itself, not the specific harmless outcome of the 2011 event.
I see. So it could happen differently another time.
Yes. Now that we know definitively that core-reflected shear waves can trigger large-scale fault slips, we have to apply this exact mechanism to other globally stressed fault lines that might react differently.
So a future SES wave could be much worse.
Right. Imagine a massive megathrust earthquake on one side of the planet. It sends a wave that dives deep through the mantle, bounces off the liquid outer core, and arrives perfectly synchronized beneath a highly stressed, locked fault line elsewhere in the world.
And if that recipient fault is on the absolute brink of failure,
Then instead of causing a slow 3-minute benign slip, that precise synchronized nudge could act as a catastrophic violent trigger.
it could just set the whole thing off all at once.
Yes, it could turn a locked fault into a sudden devastating rupture. It's essentially transferring the seismic trigger of an earthquake across the globe through the deep interior.
That changes everything about how we look at fault lines.
It really does. The 2026 discovery reframes the entire 2011 event, shifting it from an isolated surface disaster into a highly dynamic, three-dimensional planetary event.
Showing that the whole Earth is connected.
Demonstrating clearly that massive seismic forces can interact across the full depth of the Earth. It turns the planet's liquid core into a giant subterranean reflector that can beam destructive physical triggers back to the surface thousands of kilometers away.
So it really forces you to think about the whole system.
Absolutely. We started out by talking about the standard expectation of immediate visible cause and effect in natural disasters. You know, the clear fault rupture you can easily see on the surface and the immediate shaking that follows.
Right, the stuff we're used to.
But if a single massive tectonic snap can send a wave all the way down to the superheated liquid core of the planet, only to have it bounce back and physically shift an entire nation 15 minutes later, it invites us to fundamentally reconsider the hidden physical mechanics of the ground beneath us.
It really does.
What other massive, deeply buried planetary rhythms are currently echoing through the Earth, bouncing off the core, completely invisible on the surface, simply waiting for the right scientific lens to finally be uncovered?
Subscribe to the podcast series, Nuclear Locomotive, Neural Sawdust, and Synthetic. Namaste, thank you, and good luck.